This was the main point of the previous video, the geometric properties of the cross product. We have this formula here for the length of the cross product of V cross W. V cross W is orthogonal to V and W, and VW and V cross W forms a right-handed system. I don't think I drew a picture of that, so let me do that right now. If this is V, and this is W here, just generally speaking, V cross W is going to be orthogonal to both V and W, and in the way point your fingers in V, curl them towards W, it points in the direction of the cross product. Let's spend some time kind of comparing, contrasting the dot product and the cross product here. So the first thing to realize is that we have these, as I mentioned in the previous video, we have these kind of complementary formulas here. Cosine theta, there's a dot product formula for that, u dot v over magnitude u magnitude v. We can rearrange the formula for the length of v cross w into sine of theta is the magnitude of u cross v over magnitude of u magnitude of v. So the denominators here are the same. Dot product, cross product here, cosine, sine. Nice symmetry between these formulas. But there are some important ways in which they are opposites. Dot and cross products are opposites of each other. So if you do u dot u, you take the dot product of a vector itself, you get the length squared, which is going to be something big, assuming something positive, assuming that your vector is not the zero vector. On the other hand, if you take the cross product of any vector with itself, you get the zero vector. So these are opposites. Something big if you take the dot product of a vector itself, zero vector if you take the cross product of a vector with itself. And more generally speaking, u dot v is big when u and v are parallel to each other. When u and v are parallel to each other, they're pointing in the same direction. The angle between them, theta, would be 0 degrees, 0 radians. The cosine of 0 would be 1 here. So that would be relatively big. Or maybe not quite parallel, but they're close to parallel. Cosine theta would be close to 1. U dot v would be close to magnitude of u times magnitude of v. On the other hand, for the cross product, u cross v is big when u and v are perpendicular to each other. We want sine of theta to equal 1 for this to be big. Go back to this here. If you aren't changing magnitude of v and magnitude of w, how do you make the magnitude of the cross product as big as possible? Make sine theta big. Make sine theta equal to 1, which is when they are orthogonal. When theta is pi over 2 radians, 90 degrees. And then this flip-flops here. If u dot v is equal to 0, that's when the vectors are perpendicular, when they're orthogonal to each other. And if your u cross v is 0, if your vectors are parallel to each other. So parallel is big dot products, 0 for the cross product. Perpendicular is big cross product, and when I say here big, I mean the magnitude, the length of the vector is big here. U cross v is big when u is perpendicular, u is orthogonal to v, but the dot product there is 0. So important ways that there's lots of kind of symmetries, but in some ways they're opposites to each other. And maybe to illustrate a lot of this stuff, find the angle between these two vectors. I want to do this problem in two different ways. I want to do it using dot product calculation. I want to do it using the cross product calculation. So let's start off with the cross product calculation. So u cross v, I hat, j hat, k hat, 2, 2, 1, 1, 0, 1. And so this is going to be I hat times 2, 1, 0, 1 minus j hat times 2, 1, 1, 1 plus k hat times 2, 2, 1, 0. And this ends up as 2I hat minus j hat minus 2k hat. So our cross product here is 2, negative 1, negative 2. Think for yourself, what's a quick thing that we could do to check to make sure our answer is right? So this should be perpendicular to both u and v. If we take the dot product of u with u cross v, 2 times 2 is 4, minus 2 minus 2, that gives us 0. That checks out. 1, 0, 1, dotted with 2, negative 1, negative 2. 2 plus 0 minus 2 again gives us 0. That checks out. Okay, so things are looking good here for this being the cross product. And so now we are going to use this formula right here. So sine of theta is the magnitude of 2, negative 1, negative 2 divided by the magnitude of u times the magnitude of v. Check for yourself that the magnitude of u is 3. The magnitude of v here is square root 2. And the magnitude of u cross v is also 3. And so this ends up as, so magnitude here is 3 over, let's see, 3 times square root 2. So we have 1 over square root 2 here. And so we have learned that sine theta is equal to 1 over square root 2. So the only two possibilities, assuming theta is between 0 and pi, are going to be theta is equal to pi over 4, theta is equal to 3 pi over 4. How to choose between these two, we can choose in the middle of our dot product calculation. So let's go ahead and just run through the problem using the dot product calculations here. So once again, these are our vectors here. U dot v is equal to 2 plus 0 plus 1 is 3. And so the magnitude, sorry, I should write here, cosine theta is equal to u dot v is 3 divided by their respective lengths. 3 and square root 2 is 1 over square root 2 here. And so this shows us theta has to be pi over 4. Also, I should point out here, if we had just stopped here, the dot product here is positive, which means there is an acute angle between our two vectors here. So theta is pi over 4 would be the choice there. So yeah, I think this is a good practice, just working with all of these different calculations here, all these different concepts. I want to highlight how these are similar and how these are different.